calculations involved in photoelectric effect is what we are going to do today. To solve problems on photoelectric effect, we make use of Einstein's photoelectric equation that states that E is equal to W plus K, where E is product of Planck constant H and F, frequency of incident light, and W is the work function, which is the same thing as Planck constant times FO. FO is threshold frequency, which is the minimum frequency of light required to eject electrons. And Ke is kinetic energy of photoelectrons, which is half of mv squared. So, example 1. Calculate threshold frequency if the work function of the metal is 6.6 times 10 raised to power minus 34 joules, while Planck constant is also 6.6 times 10 raised to power minus 34 joules second. Calculate the threshold frequency of a metal if the work function is 6.6 times 10 raised to power minus 34 joules, while Planck constant is 6.6 times 10 raised to power minus 34 joules second. To solve this problem, we make use of relevant part of Einstein's photoelectric equation, which is work function that is equal to Planck constant times threshold frequency. So solution 1. Work function is equal to HFO. Therefore, FO we are looking for will be work function over Planck constant. Work function given is 6.6 times 10 raised to power minus 34 joules, while Planck constant is also that same value. So this will be, this is 1, this is 1. 1 over 1 is 1 hertz, because unit of frequency is hertz. So it follows that our threshold frequency is 1 hertz. Also, if we are given Planck constant and total energy of incident light, and we are asked to solve for frequency of incident light, we make use of this equation. Supposing if total energy of incident light is 40 joules, while Planck constant is 6.6 times 10 raised power minus 34 joules second. Find the value of frequency of incident light. Solution to this problem can be obtained by equating this E with HF. E is equal to HF. And E has been given, H has also been given. So we make use of F as the subject of the equation. Therefore, frequency of incident light is equal to E over H. And the value of total energy of incident light given in the problem is 40 joules. 40, while Planck constant is 6.6 times 10 raised to the minus 34. When you divide it by this, the value you have in frequency is frequency of incident light. The next example is sometimes you could be given total energy of incident light, work function, and then you are asked to calculate kinetic energy of photoelectrons. Example 3. Calculate the kinetic energy of photoelectrons if the total energy of incident light is 80 joules, while work function is 30 joules. In this problem, the whole of this is given, and the whole of that too is given, and we are looking for this. So we make K the solid formula. So we say solution 3 Ke is equal to E minus W, and E is 80, while W is 30. 80 minus 30 gives us 50. So 50 joules is the kinetic energy of photoelectrons. Yes. Any question?
Sir, please, why does threshold frequency differ in various substances?
Yes. Threshold frequency varies from 1 metal to the other, you know that different metals, they have different properties. For example, they vary in densities. Density of iron is different from density of aluminum. And so the energy that is holding electrons within iron is higher, maybe higher than that holding electrons in zinc or aluminum. So therefore, the frequency that will be used to eject electrons from iron will not be the same as the frequency needed to eject electrons from aluminum. Is that okay?
Yes.
Any other question? Okay. In the absence of other questions, remember that photoelectric effect is the process by which electrons are ejected from metal surface when light of sufficient frequency is incident on such metal surface.